Hello everyone, welcome to my lecture number 3. So in this lecture, we're gonna talk about computer architecture. So computer actually a machine. Yes, of course, a machine. So we have two kind of computer. The first one we call fixed program computer. So you can look at this picture. This is an example of a fixed program computer because it is designed for one specific purpose. All right, just a specific purpose. So, for example, this computer is designed to do a calculation. So actually, it's a calculator. So what does it mean specific purpose? So you will understand this this definition when you look at the second computer. I mean, that's the second kind of computer. So we call this one is store program computer. So actually, this computer, yes, actually you use this computer every day to play video game or watch YouTube or Netflix, for example. So, and this computer we call is multiple purpose computer. Yes, multiple purpose computer. So what does it mean? Because this kind of computer, we actually the engineer, they don't design this computer for any specific purpose. So to use this computer, you need to install the first one we call operating system. Operating system. For short, we call OS. Yes. So you need to install OS. So for example, you can use Windows. Yeah. So after you have OS, you can the next one you will install application. For example, you will install Microsoft Word. So it means when you open Microsoft Word, you can use to type in something. Yes, type in the document, or you can install video game. Yes, to play video game, or you can use what else? You can use Photoshop. Yes, Photoshop. So you can easily to figure out that the function of this computer is based on your application. So when you open your Microsoft Word, so easy can type in your document. When you open video game, you can play some game for entertainment. So it depends on this application. So actually, at the beginning, this computer doesn't design for any specific purpose. Yes. So we call this one the multiple purpose or general purpose. General purpose. Yes. So it's totally different from this kind of computer because we don't have a OS in this computer. You cannot install your own application in this computer. So this one we call fixed program. Okay. So next one, let's talk about modern computer architecture. So today we have three different kind of computer. You usually have a see around your world. The first one we call smart home. I'm sorry, it's smartphone. Smartphone. And this one we call PC, personal computer. And this one the laptop, yeah, actually, you know it, I strongly believe. So actually, even though your smartphone, iPhone 13 or some Samsung Galaxy, something like that, actually they are a computer because they have OS. And after you install OS, you can install your own application. For example, you can install Facebook, you can install TikTok, yeah. You can install a camera to capture your video or recording. I'm sorry, capture the picture or recording your own video. So actually, when you open an application, so this smartphone will do a specific function. Actually, even though your smartphone is small, they are a computer and they are general purpose computer. Yes, general purpose computer, or store computer. Okay, so nowadays on those computers actually follow exactly one architecture we call modern computer architecture. So we call the first thing of computer architecture, we have input here, and then we have output. So input is your keyboard. Yeah, of course. You can install. You can type in something, and for example, type in a number, a word, a sentence using your keyboard, or you can use the mouse to transmit your own information to the computer. All right. So the second thing is the output. Is the monitor, of course. The monitor. You can use your monitor to display your own information or the output from a function or program. You can have output is printer. So the second component is the memory. So keep in mind that this memory I want to talk about is we call RAM memory, not SSD or HDD. So keep in mind that. All right, we're gonna talk about this one later in this video and in some videos in the future. All right. So the last component is the CPU. All right, CPU. So this one is the shorthand for we call central processing. Yes, processing unit. All right. So be careful. Maybe you can heard someone say that this the big one here. You said this big one is CPU, but it's wrong. CPU. When we talk about CPU, we want to mention a very small thing here. Actually, you need to open this tower, this BC tower, to look at this CPU. All right. So CPU, I strongly believe, is one of the most complex things human have ever produced around the world. So of course we don't want jumping about CPU in detail, but for general, I mean in general, CPU have two important components. The first one is CU, because CU here, so control unit, and in this CU we have program counter. So we're gonna talk about this later. And the second one is the component to design for doing calculation. For example, we have a plus, minus, multiply, or divide something here. But I want you to remember that when your data enter input here, it must go to memory first, and then from memory they will go into the CPU. So we never ever have a situation that the data, your information, go directly from input to CPU. Yes, this one never ever happen. Keep in mind that. And then when the CPU finish their its calculation and provide output, it must go to the memory first, and then from memory they will transmit to the output. So again, just similarly, it's never ever happened the case that the output move directly from the CPU to the output. Yes, keep in mind that it's very, very important. All right. So in the modern computer architecture, we usually see this kind of figure. So the first one we have this. It can be HDD or SSD. So let's see the way you store your data. You store your picture, your video, your codes. Your program, your computer program, your Python program. Yes, your Python program. So, but CPU cannot directly process your data from HDD. Because why? Because HDD or SSD is very slow, extremely slow. So, and your computer is super fast. So if we allow CPU directly chumping the data in HDD or SD, you will waste a lot of time because this one is slow, so this one very fast. So it means you will waste a lot of time, a lot of resource of CPU, because when CPU finish something, we have to wait the data move from HDD to CPU. All right. You can imagine that you have two people, A and B. So A is super fast, all right, Superman, and this is normal human. It's very slow, and you will type in B will throw something to A, for example, throw watermelon to A, because B very slow. So when B threw a watermelon to A can cut and can catch it easily, and then A have to wait for B. So actually A will enjoy or relax almost of time. All right. For example, this one you can catch 1,000 watermelon per second, but B can just throw one watermelon per second. So A is super fast and B very slow. All right. So to handle this situation, the engineers, they input the memory here. We call RAM here. So later we compute first and store in here and store in RAM. So but RAM is still very slow if we compare to CPU. So all right, it's slow. It's faster than HDD or SSD, but it's still slow. And then in CPU we have another memory we could cache memory. It's faster. Actually, it should be fast. Yes, and then we store data here first, and then it's ready for CPU for processing, of course. Yeah. So the question is why we don't improve the speed of the storage data here, so we can directly read the data into the CPU, so it's more simple. Yeah, so it's very good idea, but the main obstacle is we will explain now. If you you should know about this one. How can I say? So you know that to store data we need space, so we call memory space. And in computer science, memory space is measured using bit unit. Yes. So unit a bit will be equal to 1 byte. Yes. And then I don't have enough space here, so let's write down here. All right. So we will have a bit equal to 1 byte. So you have 1 kilobyte be equal to 1022 byte. Yes. And you have 1 megabyte will be equal to 10,024 kilobyte. Yeah. And you have 1 gigabyte will be equal to 1024 megabyte. And then we have 1 terabyte equal to 1024 gigabyte. All right. So you can say if you try to look at I'm sorry, if you try to investigate the rise of HDD, you can say that you will cost around just $100 to buy a 1 terabyte SSD. Yes, but you may cost about the same money to buy just a gigabyte of RAM memory. Yeah, so you can see that even though your CPU very expensive, around $500. Yeah, but we have only something. I mean, usually you will have around 12 megabyte for cache memory. Yes, for cache memory in here, cache. So the problem is, if you want to have an extremely fast memory, it will be cost and expensive. Yes, but for storage, you need very big storage capacity to store the data, the video game. Maybe if you play Call of Duty, you will need around at least 100 gigabyte. Yes, for storage you need a very big capacity, so you need some kind of maybe slow but very cheap storage capacity. Yes, and for this one is for processing, so we need faster, but we can pay money. Yes, of course. So I strongly believe this architecture is the most optimal for rise and for speed. Yeah, okay. So let's talk about the next one is what computer can do. All right. Actually, computer nowadays can do a lot of things, but you can understand that computer actually is designed to do 3 things. The first one is do calculation for mathematics and logic. I mean arithmetics. For example, we have plus, minus, divide, and logic we have a and or something, and then they can do compare. What does it mean? Greater, smaller, something like that. And the next one is moving data. We will talk about moving data later, all right? But actually they have to do with 3 kinds operations. Yeah, you should get familiar with this one: operation and operator. All right, we will discuss about this one later, so don't worry. All right, so in your computer, we have a very special program we call interpreter. So this program will execute your instruction. Yes, instruction here. Keep in mind that instruction in order and interpreter. We will talk about this one later in the next video. So keep in mind that. So the next definition I want you follow, we call flow of control here. So you don't have to understand this definition now, but keep in mind that, all right? Keep it in your heart or your mind. All right. And the last thing you need to be careful is all computer program have to stop when it's done. What does it mean? What does it mean? It means you cannot run the program forever. Yes. You need to know when your program is done and it must be stopped. Yes. All right. All right. So in conclusion, so what does computer do? So we can know that computer actually do 2 kind of things. The first one is perform calculations. All right. As I mentioned in the previous slide, we have logical operations, mathematics operation, yes, and computer can calculate billion calculations per second. Yeah, of course, extremely fast for this task. And then after you calculate something, you have to computer has ability to remember the results. Yes, of course, yeah. If you cannot remember, so your computer will, if your computer cannot remember, we will lose all the data, yeah, all the calculation here. So it provide no meaning, all right? And the last one, the last question is, well, what is the definition of calculation? What's the calculation? So we have two kind of calculations. The first one is built-in calculation. What does it mean built-in? We have, it's very simple. Minus, plus, divide, multiply something. And the last one we call U-define. Sometimes you can see user-define. Oh, user-define. It means this calculation is decided by yourself. Of course, based on the basic operations. Yeah, of course. For example, you want to write a program to compare two students, for example. So compare two students in your own school. So actually, computer don't know how to compare because one student have a multiple kind of information, name, GPA, GPA, age. So what kind of attribute you want to compare? So your computer don't know, but you can design a computer to specific attribute here and compare for you. But actually it's just based on the basic operation here. All right, it's very simple. Okay, so this is enough for this video. We will talk about instruction in the next video. All right, so I hope to see you in next video about this very extremely interesting topic, instruction. All right, see you.